Welcome back, Math 140 students. This is your instructor, Cindy Enrique. So we are going to go over section 12.2, which will talk about the ellipses. So the ellipse, it can either be vertical or horizontal. So vertical, like it looks like in the picture, it's more stretched up and down, versus the horizontal is more stretched out horizontally, okay? So for the ellipse, you definitely want to take into consideration where your center is, where your vertex is, and where your co-vertex is going to be. And also, one thing that doesn't show up on this diagram is how to find your C value, or actually it'll come up in your applications, and we can actually say it's your B squared value. So your B squared is going to be equal to A squared minus C squared, and that's going to relate where your C is going to be your foci. So we'll just keep that in mind and just know that that's going to come into play at one of our last problems, which would be an application problem. So let's go ahead and just start with the basics. So we have an ellipse centered at the origin, which is at 0, 0. So if it's along if the major axis is along the x-axis, so that would be one that's stretched horizontally, then this would be what the equation looks like, where A is bigger than B, okay? And if the major axis is stretched along the y-axis, then this is what it looks like, where the B squared is underneath the x squared and the A squared is underneath the y squared. So basically, you just want to determine, hey, is your A bigger or your B bigger? And that's going to determine what type of ellipse you're going to have, whether it's stretched horizontally or stretched vertically. And your center is going to be, well, at least for now, it's going to be at 0, 0. When it's not centered at 0, 0, we have a different formula. So just know that it's going to be centered at 0, 0 because the x isn't being added or subtracted by anything inside the parentheses, and the y is the same thing. So for an example, it says for number 1, identify the center. Well, I know that my center, that I'm really focusing on this x and this y. So there's nothing that's being added or subtracted. So my center for my h and my k value are going to be 0, 0, okay? And then here, remember, your A is always going to be bigger than your B. So your A squared, if you want to think about it, you have two choices. It's either going to be 16 or 36. Which one is bigger? The 36. So then your A is going to equal to 6. So I know that my A value is equal to 6. Well, then that tells you that your B squared is equal to 16. So if you were to square root it, the square root of 16 would be 4. So now I have found the center and my values for my A and my B. Now for number 2, I'm going to have to get it into the ellipse form. So what I always have to do for an ellipse is make sure that it's equal to 1. So ellipse always equals to 1. So what I'm going to do first is I'm going to add 4 to both sides. So that way I can get my 4x squared plus my y squared is equal to a positive 4. Now, because I want this to equal to 1, I'm going to divide everything by that numerator, which is 4. So I'm going to divide everything by 4. So that gets me and I'll write it over here, an x squared plus y squared divided by 4 is equal to 1. And remember that whenever you have a fraction or a number, you can always make it a fraction if you put a 1 underneath. So then here, my A squared, remember your A squared is always the biggest value, so that would be 4. So that means your A is equal to 2. And it would also mean that your B squared is equal to 1, so your B is equal to 1. So now I can say that my center for h and k is 0, 0. My a is equal to 2, and my b is equal to 1. Okay. Now, let's go ahead and graph the ellipse, okay? So for this ellipse, I know that I'm going to have my center. My center is at 0, 0. And I also have that my a squared value, remember it's always the biggest value, which would be 25. So my a is equal to 5. So here it's along the y-axis. So along the y-axis, that's where it's going to stretch out. So from the center, I'm going to go up 5. And from the center, I'm going to go down 5. Okay? Now, I'm going to look at my x value. So that would be my b squared. That's equal to 4. So if I were to square root it, that would be 2. So along the x-axis, I'm going to go 2 to the right and 2 to the left. And that gives me my ellipse. Okay. So that's going to be the shape of my ellipse. So that's what it is when it's given to you. The equation is given nicely to you. When the equation is not given nicely to you, you just have to do a little bit more work, but it's still doable. So I'm going to add 144 to both sides. So then I'm going to have a 4x squared plus a 36y squared is equal to 144. Remember that your goal is to always get it equal to 1. So that means I'm going to divide by 144 everything. So on your calculator, you're going to do 4 and divide it by 144, and you're going to get that this is going to be x squared over 36. And then you're going to have 36 divided by 144, and that's going to be y squared on top and 4 on the bottom equal to 1. And again, remember, your biggest denominator is your a squared. So a squared, what's bigger, 36 or 4? That's right, 36 is bigger. So then a is equal to 6. You also have your b squared. That's the other denominator you did not use. So my b is equal to 2. So now I know that my center was at 0, 0. And now I look at my equation. So this is the equation I'm looking at. Then along the x-axis, I know I'm going to be going 6 left and right. So I go 6 to the right from the center and 6 to the left from the center. Now along the y-axis, that denominator is 4. So that means I'm going to go up 2 from the center and down 2 from the center. So that's going to be the shape of that ellipse. Okay? So it really just kind of depends on what your denominators are for your x squared and your y squared to see how it's going to get stretched out. So that is how you can tell the difference between the ellipses here. Okay. Now we're going to be doing things a little bit differently. Now it's giving you a graph, and the question is asking you, hey, find the equation of the ellipse from the given graph. And you're just like, okay, well, let's see. Well, I know that I have my center at 0, 0. So that's perfect. So I have my center at 0, 0. I also know that the general equation that I'm looking for is my x squared over something and my y squared equal to 1. Now, the denominator is either going to be an a squared or a b squared. But I'm going to determine that from the graph. So here, this is a 4, 0. So that means a value would be 4. Over here, I have it as a 0, 3. Okay. So So what number is bigger, 3 or 4? 4 is bigger. So I would say that my a is equal to 4. Therefore, my a squared is equal to a 16. And it's longer along the x-axis. So I'm going to have my a squared here and my b squared over here. And my b, it looks like it's 3. So if I were to square that, that would give me 9. So now I have x squared over 16 plus my y squared over 9 equal to 1. So that is going to be the equation of this ellipse. Now, if I'm looking at this ellipse, again, I'm going to have my center. It hasn't changed. It's still at 0, 0. Okay. Now, let's determine this. So here, that's a 2, 0. And over here, that's a 0, 5. So it looks like this one is bigger. So I'm going to have that my a value is equal to 5. So a squared is equal to 25, which then tells me that my a value is equal to 2. So then a squared would equal to 4. And remember, the general term that I'm going to have is x squared plus my y squared equal to 1. And since it's longer along the y-axis, that's where the a squared is going to belong. So here, my a squared, we already identified that. That was going to be my... Oh, I messed up, didn't I? I said a twice. I already signified that a is bigger. So that gives me my 25. And I meant to say b value is equal to 2. So my b squared is equal to 4. There we go. Okay, and so that's going to be the equation of the ellipse. Now we're going to have an ellipse not centered at the origin. So that center is going to be HK. So again, the A is always going to be bigger than your B, which tells you whether it's going to be stretched out along the x-axis or stretched out along the y-axis. So here we want to identify the center. So you're just like, okay, my center, I know that to be the variables h and k, and we have h and k. So my center for my h value is a -4, and the value for k for my center is going to be a +5. And I also know that the a squared value is going to be the bigger denominator. So that's going to give me 16. So that tells me that a is equal to 4. Which means that b squared is equal to 9, so that b is equal to 3. So that is going to be my final answer. And for number 2, I still have my h and my k. So it looks like my center is going to be a 1, -3. And it looks like the bigger denominator, a squared, is equal to 81. So a is equal to 9, which tells me that my b squared is equal to 36. So b is equal to 6. So I have my center at 1, -3, my a at 9, and my b at 6. Okay? Well, I hope this is helping you guys. And the next step is we are going to be graphing these ellipses. So to graph this ellipse, I need to find my center first. So my center, I have my h and my k. So here my h is there, so that's going to be a -6. And my k is here, so that's going to give me a -3. So you can think of it as your center being at -6, -3. So that is here. Now I'm going to look at the denominator on x. The denominator on x is 9. So I can think of that as my a squared is equal to 9. So my a is equal to 3. So along the x-axis from the center, I'm going to go 3 to the right. I'm also going to go 3 to the left. And now my denominator on the y plus 1, or the y plus 3, I have a 1 underneath there. So you can think of it as your b squared equal to 1. So your b is equal to 1. So now I have my ellipse. Okay. So let's go on with letter B. I'm going to have my center here. And I have my h and k value, so this is 2 and negative 4. So my center is at positive 2, negative 4. My a squared is 25, so a is equal to 5. So along the y-axis now, I'm going to go up 5 from the center. I'm going to go down 5 from the center. Now, I'm also going to have my b squared value, which is 4. So the square root of that is 2. So along the x-axis from the center, I'm going to go 2 to the right and 2 to the left. And now I have the general shape of my ellipse. So that is what my ellipse looks like, okay, according to this. Now, for the next example, it says rewrite the equation of the ellipse in standard form and graph it below. So I know that if I want it in standard form, then I would need to make sure that it's equal to 1. So remember that all the ellipses equal to 1. So the first thing I'm going to do is I'm going to subtract the 139 to both sides. So I'm going to have my 9x squared minus 72x plus y squared minus 4y is equal to a positive 139. Now from here, I see that I have a leading coefficient of 9. So I'm going to go ahead and kind of pull that 9 out just from the x's. So I'm just looking here. So I'm going to have a 9 on the outside. So I'm left with an x squared. And if I did 72 divided by 9, that's going to give me an 8. So you always want to make sure that that leading coefficient, if possible, is always going to be 1. And if not, you can force it to be a 1. So here on that y squared, it's already a 1. So I don't have to worry about it too much. So that doesn't change the inside as a y squared minus a 4y equal to your 139. So now what you want to do is you're going to do the completing the square, just like we did before. So hopefully you guys are getting a little bit more practice with this. So I'm going to have my parentheses squared. I have x minus, and here, since I have my value of 8, well, if I were to divide that by 2, so let's say over here, my b value is 8. So if I divide that by 2, 8 divided by 2 is 4. And then I also have to square it, which is 16. But now I can't forget that there's a 9 out in front. So this is going to get multiplied by a 9. So I'm going to have the square, which is 16 times 9, be 144. So now my b divided by 2 value, when I plug that in, that's going to be 4. And the value that I'm adding to the opposite side, it's that b divided by 2 squared times 9, so that's going to be 144 that I'm adding as well. So now for my y values, I have y minus, now I'm going to think about this. I have my b value as a 4. So if I were to divide that by 2, that's 2. And if I were to square that, that would be 4. And the number out in front is 1, so that doesn't change. So I'm going to have my b divided by 2 value that I plug in, which is 2. And then I'm going to square it and add it to the opposite side, which is 4. So now I have 9 x minus 4 squared plus y minus 2 squared is equal to, and I'm going to add all those numbers together. So I have 139 plus 144 plus 4. That's going to give me 287. Okay. Oh, and I noticed I did something wrong, but this is why we like to check our work. And I wrote all my steps down. This is a negative 139. So that should be a negative 139. So that should be a 139. So that should be a negative 139. So notice how I'm making sure that this is negative 139. That's where I thought my values kind of messed up. So that's perfect that I wrote all my steps because I don't have to erase anything. I just have to make sure that that value is negative 139. So negative 139 plus my 144 plus 4. That looks like a little nicer number. And that number is now 9. There we go. That makes more sense. So whenever you think something is weird, go back and check. This is what mathematicians do. They're not always going to get it right on the first try. So once you get something that's a little bit weird, go back and retrace your steps. Hopefully you wrote all your steps down so you can go back and check it. And remember that you always want your denominator to, or you always want it to equal to 1. So I'm going to divide everything by 9 here. So then that will give me an x minus 4 squared over 1 plus y minus 2 squared over 9 equal to 1. So now I can very easily say that my center is at 4, 2. So I'm going to go ahead and write that center, or draw that center, 4, 2. I also know that along the x-axis, I'm going to go 1 in each direction. And along my y-axis, I have my a squared equal to 9. So a is equal to 3. So from that center, I'm going to go up 3. I'm going to go down 3. So now I have my ellipse. So that is what my ellipse is going to look like. Okay. So let's go ahead and do this process all over again. So I'm going to have my 16x squared plus 96x plus 100 and, oops, not 125, but just regular old 25y squared minus 150y equal to, and this is where I add 31 to both sides. Okay. Now, the next part is I am going to kind of take out that value to make sure that that leading coefficient is 1. So here, that value is 16. So you remember, your goal is to make that leading coefficient 1. So 96 divided by 16 is 6. And here, that leading coefficient is 25. So I'm left with the y squared, and 150 divided by 25 is 6. Okay. Now, I'm going to get ready to do the completing the square. So when I'm completing the square, I'm going to have my 16x plus squared, and then my 25y minus squared is equal to, and now this is where the magic is going to happen. So over here, I'm going to think about my b value being equal to 6. So 6 divided by 2 gives me 3. And if I were to square that, that would be 9. But remember, we always multiply by the number out in front. So I'm going to have my 9 times 16, which is 144. So my b divided by 2 value, the value that I'm plugging in here is 3. And over on this side, I'm going to add my 144. Now, for my other b value is here. It's also 6. So really, I'm going to have the same thing, except the only difference here is the number out in front. The number out in front in this case is 25. So I'm going to have 9 times 25, which is 225. So now I have all of my moving parts. So my b divided by 2 that I'm plugging in is going to be my 3. And I'm also going to add my 225 to the opposite side as well. So now I have 16x plus 3 squared plus 25y minus 3 squared is equal to, and now I have my 31 plus 144 plus 225, and it's going to give me a big number, which is just 400. So now, since I want it to equal to 1, because the ellipsis is always equal to 1, I'm going to divide everything by that 400. So again, I'm using my calculator, and so I'm going to get my 16 divided by 400, which is going to give me the 25 in my denominator. And so again, my fraction, where I have 25 as my numerator and 400 in my denominator, I'm going to get a 16. So here's my equation. So I can tell you that my center is going to be -3, +3. So I can go ahead and start graphing this. So I have my center at -3, +3. That's there. And I know that along the x-axis, I go along 5. So 5 to the right, and then 5 to the left. And I also have that along the y-axis, I'm going to go up and down 4, since the square root of 16 is 4. So my ellipse, not the best circle, but it's a circle. Oh, sorry, not a circle, an ellipse. Maybe I can draw it a little bit better. I think I can do better. Maybe not. Okay, maybe that's a little bit better. So there we go. There is my circle. Okay. And now, your favorite part, the application problem. It says, a planet moves in an elliptical orbit around its sun. The closest the planet gets to the sun is approximately 40 AU, and the farthest it gets from the sun is approximately 80 AU. The sun is one of the foci of the elliptical orbit, letting the ellipse center at the origin and labeling the axis in AU. The orbit will look like the figure below. Use the graph to write an equation for the elliptical orbit of the planet. So you might be thinking, like, what did I just read? Well, it just says use the graph to write the elliptical orbit of the planet. So you know that this is an ellipse. So that's great. You know it's going to be an ellipse. the other thing that you are going to know is that it's stretched out, at least it looks like it's stretched out along the x-axis, okay? So I know I'm going to have my, let's write that in black, for my general equation, x squared over a squared plus my y squared over b squared is equal to 1. And I know that my center here is 0, 0, because it tells us that we're at 0, okay? So here, it looks like from the center going out, okay? Maybe I should highlight that more than anything. So from the center going all the way out, that's going to give me negative 60, okay? And it'll also give me positive 60 and I go in the other direction. So that tells me that my A value is going to be 60. So then my A squared would just be 60 times 60, which would be 3,600. So now I'm like, okay, I'm halfway there. I have my center, I have my A value. So the only thing else that I'm missing is my B value. That's the thing that I don't know what that is. So it was that equation that I gave you a while ago from the very beginning, where I said that I have my foci. That's going to be my C value. And then I have this equation that B squared is equal to my A squared minus my C squared, okay? And I know that the foci is C. So here, the foci is here. That represents the foci. So the foci, in this case, is 20, 0. So it tells me that C is equal to 20. So now I have some values to plug in. I know that B squared is equal to my A squared, which is that 3,600, minus my C squared. Well, C is 20, so 20 times 20 is 400. So I'm going to get that 3,600 minus 400 is going to give me B squared value of 3,200. So now I can give you the equation. I have x squared over my A squared. And remember, my A squared was 3,600. And my B squared is 3,200 equal to 1. So that is going to be my equation. Okay. The next thing that we're going to go over is hyperbolas. We have hyperbola centered at the origin at 0, 0. So this is where it's along the x-axis, so these are horizontal, okay? And we also need to know the equation, the vertices, the co-vertices, the foci, and the asymptotes. The asymptotes are these lines that are dotted. So just to make sure that you understand, these are my asymptotes here. Okay? So that is my asymptotes. And I also have the vertex, which is here and here. Okay? All right. And I also have a type 2 for my hyperbola, where it's going to be vertical. That's going to be along the y-axis. So notice the difference between these two is that the horizontal goes along the x-axis and the vertical goes along the y-axis. Also notice the equation. For the horizontal, it's x squared comes first. In the vertical, it's y squared that comes first. Okay? So we're going to be using these equations and these formulas for the problems below. So it says, graph the given hyperbolas using transverse axis vertices and co-vertices. So you're just like, okay, well, I know for a fact, at the very least, that my center here is going to be at 0, 0. So might as well just draw it. 0, 0. So now I'm going to look at my x and y values. So I know that x squared came first. So I know that I'm going to have the one that's going to be going along the x-axis. So notice here I'm going along the x-axis, okay? So this is the shape that I'm going for. My vertices are plus or minus a, where a is the denominator of x. So I know here that my a squared is equal to 4. So a is equal to 2, which tells me that my b squared is equal to 25, so then b is equal to 5. So I know that my vertices are going to be at 2, 0 and negative 2, 0. Because remember, the vertices, they said we're at plus or minus a, comma, 0. And they also said your co-vertices we're at 0 plus or minus b. That gives me 0, 5 and 0, negative 5. So along the x-axis, the a squared value is 4, so I'm going to go 2. Those are my vertices. My co-vertices are in green, so on the y-axis I have about 5. Okay. So that gives me the shape for those asymptotes. And the asymptotes are always on the corners of the boxes, and it goes through the center. And so I have my actual hyperbolas now, and remember it's along the x. So that is what my hyperbola is going to look like. Now for number 2, I can see that this is going to be along the y-axis because that is what is being is what I see first. It's the y squared minus the x squared. And I still have my center at 0, 0. And so just to kind of look at this, right? I have my vertices at 0 plus or minus a now. So a is still going to be the denominator of your first fraction no matter what it is, but the vertices are slightly different. It's 0 plus or minus a. So here my a squared value is 16, so a is equal to 4. So I'm going to have my vertices at 0, 4 and 0, negative 4. Okay. Next I'm going to have my co-vertices. So the co-vertices, if you look at this formula, right, the co-vertices, it says it's plus or minus b, comma 0. And here my b squared value is equal to 25, so b is equal to 5. So I'm going to have my co-vertices at 5, 0 and negative 5, 0. So going through the corners, these are going to be my asymptotes. And remember, since the y came first, it's going to be along the y-axis. Okay, so that's what my hyperbola is going to be looking like. Now, for this one, I have to get it into that standard form, so I'm going to have to do that completing the square. Remember, your goal is to always get it equal to 1. So I am going to add 144 to both sides. So I can have a 4y squared minus 36x squared is equal to 144. Now I'm going to divide everything by that 144 so I can get it equal to 1. So on my calculator I have 4 divided by 144, and that is going to give me y squared on top and 36 on the bottom. And then I'm going to have my x squared on top, and my fraction, when I divide 36 by 144, that gave me a 4 in the denominator, and this is equal to 1. So my a squared is equal to 36, so a is equal to 6. So I have my vertices at 0, 6, and 0, negative 6. I have my b squared is equal to 4, so b is equal to 2. So my co-vertices is 2, 0, and negative 2, 0. So I still have my center at 0, 0. I have along the y-axis my vertices, which is 0, 6, and 0, negative 6. I also have my co-vertices along the x-axis, where it's 2, 0, and negative 2, 0. So now to draw the asymptote, it goes from the center through the opposite ends of the box. And since the y came first, then it's along the y-axis. Okay. Now I'm going to do the exact same thing with number 4. So I am going to get the 36 on the opposite side, so add 36. So I'm going to have a 9x squared minus 4y squared is equal to a positive 36. Now I'm going to divide everything by 36. So I have x squared up on top. 9 divided by 36 gives you a 4 on the bottom. Oh, that looks more like that should have been a y squared. 4 divided by 36, that should give you a 9 on the bottom, and 36 divided by 36 is a 1. So again, I have my center at 0, 0, and I'm also going to have now my vertices. My a squared is equal to 4, so a is equal to 2. So I'm going to have my vertices at 2, 0, and negative 2, 0. My b squared is equal to 9, so b is equal to 3. So then my co-vertices are going to be at 0, 3, and 0, negative 3. And now I get to draw my box. And the asymptotes goes from the center through the edges. And this one, the x came first, so this is along the x-axis. Okay, and that is my asymptote, my hyperbola. Now, we're also going to have hyperbolas not centered at the origin. So when it's not centered at the origin, our center is now going to be HK. Okay, and our vertices are going to switch a little bit. Same with our co-vertices. And we may or may not be talking about our foci. Okay, and there is my other hyperbola, not centered at 0. That's going to be along the y-axis. Okay. So it says graph the hyperbola given below using transverse axes, the center, the vertices, and the co-vertices. So, okay, here we go. I know at the very least what my center is. My center is -2, -1. So there is my center. The x came first, so I know it's going to be along the x-axis. So then here, I think it's better to just kind of draw it out first and then tell you what the vertices are going to be. So since the x came first, I know that that's going to be my vertices. I'm going to have 2 separate ordered pairs. So let's think about that. Here's my center. So if I go to the right from the center, what's that ordered pair? Well, that ordered pair looks like it's 0, -1. And if I go 2 in the opposite direction to the left from the center, that looks like I'm at -4, -1. Okay. Now I'm going to deal with my co-vertices. So the co-vertices are going to come from that 16. So I know that I'm going to go up from the center 4. And from the center go down 4. So let's see where that lands us. So if I went, So if I went up 4, that new co-vertices is going to be -2, +3. And the other ordered pair down there is a -2, -5. And so that is what that looks like. And so since the x came first, it's going to be along the x-axis. And that is what my hyperbola looks like. Now for number 2, I can see that the y comes first. And I also see here that I'm going to have a denominator of 1. So first I'll start with my center. My center would be a +3, +2. And if you want to think about that y coming first, but the y is always attached to that k value, and x is always attached to the h value. So your center is still hk. So then my center is going to be a +3, +2. So there is my center. So I know that my vertices are going to come from this denominator underneath the y. That denominator is 1. So from that center, I'm going to go over 1 to the right. Oops. Sorry, guys. Let me redraw that. So I had to remember what direction I'm going here. It's the y here, so I'm going to be going up 1. So then that vertices is going to be 3, 3. If I go down 1, that's going to be 3, 1. So then my co-vertices along, so this is my 25, so that's going to be 5. So from that center, I'm going to go over 5. So that's going to give me the ordered pair 8, 2. Now I'm going to go to the left 5. So that ordered pair is negative 2, 2. So now I have my co-vertices. So now I have the general shape. So it's that rectangular box shape. And this is where you go through the center to the edges of your box. And remember, this was along the y-axis since y came first. So that is what my parabola looks like. Okay. Now it's telling me to write my parabola in standard form. So if I'm going to write my parabola in standard form, then I know that I need to add that 356 to the opposite side. So I'm going to rewrite this as a 25x squared plus a 100x plus 16y squared minus 96y equal to 356. The next thing you want to do is make sure that that leading coefficient is 1. So when I bring out that leading coefficient, 25 is what I'm going to be pulling out. So I have my x squared plus, and I have 100 divided by 25, which is 4. And now that leading coefficient on the y's is 16. So I'm going to have my y squared minus, and 96 divided by 16 is 6. So this is where you take the value and you divide it by 2. And you add it to the opposite side. So let's think about this. So I have 25. I have x plus, I'm going to square it. So I'm just setting up my outline. Okay, so I'm looking at this 4, and I'm going to divide it by 2. So if I have my b equal to 4, then my b divided by 4, so 2 divided by 2 is 2. And then if I were to square that, that would give me 4, but I can't forget that I'm multiplying by the number out in front. So I would have a 4 times a positive 25, which is going to give me 100. So I'm going to add over here 100. Now, over on this side, I'm going to look at this b value. That b value is 6. So if I divide that by 2, that's 3. And then I'm going to have to square it, which is 9. But I also have to multiply it by the number out in front. The number out in front is 16. So I'm going to have 9 times 16, which is 144. So I'm going to add 144 to the opposite side. So now I have 25 x plus 2 squared plus 16 y minus 3 squared. Now I'm going to add all these numbers together. It's a 356 plus 100 plus 144. And that gives me 600. And so I'm going to divide everything by that 600. So on my calculator, the fraction 25 divided by 600, that gives me a 24 on the bottom. And if I do my fraction where 16's on top and 600's on the bottom, I get a And so when I did the 16 divided by 600, I got a 2 out in front and a 75 in the denominator. And 600 divided by 600 is a 1. And I know that this is parabola, but it really should have said hyperbola. And actually, this is actually not hyperbola. This is actually an ellipse because it's added together. So I'm thinking something went wrong here, but that's okay. Let's think about that for a minute. So that one wasn't the best example, but that's okay. You guys kind of get the gist of it at least. So this is actually an ellipse. So I'm wondering if there was a typo in one of my original equations. But I'll worry about that later. Sorry guys if that was a little bit confusing. I just know that the hyperbola has a subtraction, and this is not a parabola because both the x and the y are squared, which is actually kind of going to be tying into section 12.3, but we're not quite there yet. So maybe number 2 is going to be a better example. So for number 2, I'm looking at this and I'm like, okay, well, I have my x's and my y's, and the first thing I want to do is add the 101 to both sides. So that'll give me a negative 9x squared minus 54x plus 4y squared minus 16y is equal to a positive 101. And remember, you want that leading coefficient to be 1. So I have a negative 9 that I'm going to pull out. So I have an x squared. And I have a negative 54 being divided by negative 9, which will give me a positive 6x. And it looks like I have a positive 4 as that leading coefficient that I'm going to pull out. So if I have a negative 16 being divided by 4, that's going to give me a negative 4y. Okay, so let's try this again. So I'm going to have my negative 9. I also have my positive 4 equal to my 101. So in here, I'm going to be dealing with that x value. So this is my 6. So b is equal to 6. So if I divide that by 2, that's 3. And if I were to square that, that gives me 9. But don't forget, I'm multiplying it by a negative 9, since that's the number out in front. So 9 times negative 9 is a negative 81. So I'm going to have inside here my b divided by 2, which is a positive 3. And on the other side, I'm going to subtract my 81. Now I'm going to be dealing with my y. So for my y value, I have my b, which is 4. So if I divide that by 2, that's 2. If I were to square that, that's 4. But don't forget, I'm multiplying by the number out in front of it, so that's a 4. So I have 4 times 4, which is a positive 16. So now I have negative 9, x plus 3 squared, plus 4. Oops, I forgot to write my b down. That was going to be a negative 2. So I have 4y minus 2 squared is equal to, and I'm going to add all those numbers together. So 101 minus 81 plus 16. That's equal to a positive 36. So I'm going to divide everything by 36. So my fraction, negative 9 divided by 36, I'll have an x plus 3 squared over 4, and that's negative, plus my y minus 2 squared, and my fraction, 4 divided by 36, that's going to give me a 9, and I also have this equal to 1. So to rewrite it, the subtraction you want in the middle, so I'm going to have this as y plus 2 squared over 9 minus my x plus 3 squared over 4 equal to 1. So now this hyperbola makes a lot more sense. So this is a way better example than the one above. I do believe that example number 1 there is an error, not with my work, but with the original equation. But for number 2, I definitely see the hyperbola there. I have the subtraction, it's equal to 1, and I have my y squared that came first. Okay. So here we go. We have the summary of the conic sections. So we have the x minus h squared plus y minus k squared is equal to my radius squared. So there's no fractions here, and that's going to give you your circle. The parabola only has the squared on one of the variables, not on x and y, but either x or the y. I have the ellipse, which is always equal to 1, and there's addition between them. And I have the hyperbola, which is equal to 1, and there's a subtraction between them, okay? So we want to identify whether it's a circle, a parabola, an ellipse, or a hyperbola. So let's look at this first one. Well, I know that I have an x squared and I have a y squared, and it's equal to 33. So I'm just going to kind of simplify this just a little bit. So I have this as a 10x squared plus 16x plus my 10y squared minus 24y is equal to a positive 33. So from this equation, I can see that both the x squared and the y squared are both positive. So if I'm thinking about the hyperbola, it can't be the hyperbola because both the x, So it's a process of elimination. If the x squared and the y squared are both positive, then it tells me that I can rule out the hyperbola because the hyperbola is a subtraction in the middle. I can also rule out the parabola because it only has one squared in one of the variables. So now the question is, okay, well, is this a circle or is this going to be an ellipse? Well, if it was going to be an ellipse, well, I would have to work it out. So let's think about this. So the x squared and the y squared have the same coefficient, which is 10, that 10x squared and that 10y squared. So I can totally tell that it's not going to be the ellipse. So what I do have indeed is going to be the circle. Okay, so let's go to the next one. So again, a big part of it is just kind of making sense of it for yourself. So here I have my 6x squared minus my 16x minus my 32y minus my 14y is equal to a positive 96. So I'm looking at this, I have a 6x squared and I have a negative 32y. Oops, not a negative 32y squared, of course. So looking at that y squared term, the fact that it's negative, the only one where it has a negative in front of the y squared is going to be a hyperbola. So I already know because it's negative, it's going to be a hyperbola. Okay. And then, so for the next one, I have this 33x squared plus 24x plus 2y squared plus 3y is equal to a negative 139. So my options are circle, hyperbola, ellipse, and parabola. Well, I know that because I'm looking at this 33x squared and this positive 2y squared, that they're both positive, so it cannot be a hyperbola. I also know that it can't be a parabola because both of them are squared. So it's either a circle or an ellipse. Now with the circle, the leading coefficient on the x squared and the y squared are not the same. So because they're not the same, then it tells me that I have an ellipse. Okay. So now that brings me to my last bit, which is here. So notice how I only have one term that's squared. I only have x squared. I do not have a y squared term. So this one, I automatically know that this is going to be my parabola. I only have an x that's being squared. There is no y squared. Okay? And so that is the end of section 12.2. If you guys have any questions, please feel free to email me or contact the Math Success Center for free online tutoring. Thank you.